Now, so what I will do, let me first a small thing, I think small concept still we need to understand and then Hmm. Okay, let me just share my desktop. Okay. Um, what is happening? It's not clear to me. Hmm. So, so can you see my desktop? Hello?
Yes, sir.
Hello? Can you guys see my desktop?
Yes, sir.
Okay, you guys need to little speak up, it's a bit difficult if you guys don't speak up. And so this is one of the reason I hate teaching online. Um, okay, so one thing what we want to add today is November 2, 2022. So one thing I want to, you know, we want to continue on this um, journey of testing of hypothesis. So suppose it's a example of testing of sample proportion. So suppose your null hypothesis is equal to P naught versus alternate is P less than P naught. Suppose this is the test that you want to do, and you have a bunch of, so one test you have come up with called reject H naught if P hat is less than some cutoff point, and Your P hat is S by N. S is the number of successes and N is number of samples or events. Okay. Now what you do is we look into two kind of error. One is probability of type 1 error. Type 1 error, which is probability of reject H naught, given that H naught is true. And what we do, we say that, okay, this this reject this decision rule, is good, but I don't know the value of C. So we have to come up with a C, a cutoff point. Right? Now the problem is, if you, and there are two kind of error that we may commit if we choose C to be not properly. So this is probability of type 1 error. Another is probability of type 2 error. Probability of type 2 error. Probability that which sorry, fail to reject fail to reject H naught when H naught is false. So these two we have discussed. One thing we have not discussed is called power or statistical power. Statistical power. So it's very simple. Essentially, statistical power is 1 minus probability of type 2 error. Type 2 error. So essentially, statistical power is probability that reject H naught when H naught is false. Indeed, it is false. Okay. So this is what statistical power is. So three concepts: probability of type 1 error, probability of type 2 error, and probability of statistical power. So these are the three concepts. So generally what happens, we try to bind the error, we try to bind the probability of type 1 error by some upper bound, say alpha. Okay. And then once we do that, then we try to find the test, try to find the test whose statistical power is max. Statistical power is max, or you can say probability of type 2 error is minimum. Okay, this is typically what we do. Now, what I mean by statistical power is find the test whose statistical power is max. So let us try to understand this concept. Now,
Hello, sir.
what happens is suppose let us make two tests. So this is one test. So test one is you basically reject H naught if P hat greater than C, where C is P naught plus Z alpha square root of P naught into 1 minus P naught by N. So this is one test. Is there any other test we can think of? Is there any other way to test this hypothesis? We can always say that we do know that S follow binomial NP. So if P naught, if H naught is true, then you reject H naught if S is less than some cutoff point C. S is less than C. Okay. So such that now how you define C, such that probability of S less than C given H naught is true will have a upper bound of alpha. Okay. So you can see we are doing the same test. Same, there are only one single null hypothesis. One is saying P equal to P naught versus alternate is P, say, less than P naught. We have the same data, S and N. That's all we have. Now we have come up with two possible tests. Possible way to test. Can you tell me what is the fundamental difference between the test 1 and test 2? Can anybody tell me what is the fundamental difference between the test 1 and test 2?
One of them is using the uh, sample proportion for checking, and the other one is using the number of successes.
Yeah, that's obvious. But there is another fundamental difference. Just a minute, guys. Yeah, look at carefully. I mean, there is a fundamental difference. Let me share the share my pad. Yeah. So there is a fundamental difference between the this test 1 and test 2. And I want you to recognize that fundamental difference. Yes, I mean, obviously one is with the proportion, p hat is all about s by n, and then in this case it is by s, directly s, which is kind of obvious. Then we can say, sir, this is a simple, this is a simple one-to-one, estimated is simple one-to-one, then how it is going to matter in the final testing of the final decision. It's not going to affect my life in any way, but there is a fundamental difference. And I want you to recognize that fundamental difference. Mahid Jain, first test is based on parameter and second test on random variable, completely wrong. You cannot develop a test based on parameter. Okay. So if you look into the first test, it is based on only random variables. The only thing it was involved is P naught, and P naught is also going to be involved in the second test, because S is going to follow binomial n P naught, and in this calculation, P naught is going to play a role. So this is effectively same thing. Anything else? There is a fundamental striking difference between the two. Any guess? So look, what is the, and I'm not sure what is wrong with, I'm telling you guys, we are assuming distribution for second test. Okay. What about the first test? We are not assuming any distribution for the first test.
So in the first test, we're using the CLP.
So what distribution we are assuming for the first test?
Normal distribution.
Normal. Exactly. That is the fundamental difference, that you are assuming your sampling distribution of, so what is your estimator here? Your estimator is p hat, and you are assuming it is following normal with P naught and P naught times 1 minus P naught by N. And here, what is your estimator? Your estimator is S. Your estimator is S, and S is following binomial N, comma, P naught. Correct? Now, in both cases, you have fixed your type 1 error to be alpha or below alpha. Then this distributional assumption is going to affect a role on your either type 2 error or statistical power. So one distribution will definitely help us to reduce the type 2 error more or increase the statistical power. Question is which one? So with that, of course, we have to do the rigorous calculation to figure out which one. But do you understand the concept here? So again and again, I'm telling you, the focus will be always, you have to keep this thing that whenever you are doing a statistical inference, you are estimating something, you are using an estimator, you are using a statistic, and that estimator or statistic is going to have a sampling distribution. And that sampling distribution is going to play a crucial role in the accuracy, in the performance of your statistical decision. Okay. All right. Next, what I'm going to do, I'm going to
So I had a question.
Mhm.
So why do we actually define power to be the probability of rejecting H naught when H naught is actually true? Why can't we just define it to the probability of like the other correct decision? Like we have two possible correct decisions, and we define it to be one of them. Like why not the other one?
I don't get your point.
Okay. So we define power of the test to be probability of rejecting H naught when H naught is actually false. But
No,
we can also be
probability of
rejecting H naught when H naught is actually false. This
or
is the power
type,
of our
type 1 error.
power of our test.
No, no. Um, yeah, power of a test is probability of rejecting H naught when H naught is false. Correct.
So why can't we define it probability of not rejecting H naught when H naught is true?
So not rejecting H naught when H naught is true is 1 minus probability of type 1 error.
Yeah.
Correct. So
Yeah.
you have already decided you want to keep the type 1 error is alpha. So obviously the opposite will be 1 minus alpha. It's trivial.
Yeah, but like why did we choose power to be 1 minus beta and not 1 minus alpha in the first?
Because we have already fixed alpha.
Yeah.
The
Okay.
what we don't have control on the beta,
Hmm.
right? So that's why. Okay, so you want to reduce the beta. Essentially, you want to figure out a test where beta is minimum.
Okay.
Understand?
Yeah.
Okay. All right. So let me create a markdown file. Okay. Mm. Now, what we are trying to do is equal to P naught versus H1 is P is strictly less than P naught. Okay. Now, suppose we have this equals number of successes number of success and n is the number of events. So, okay, so we are starting with this. Let me just delete it. Now we have two tests. Test one is essentially reject H naught, reject H naught if E hat is greater than C where C equal to P naught plus Z alpha and square root of function E naught into 1 minus E naught by N. And so this is so this is my test one, and this two is test two is reject H naught if S is less than C, where S C binomial N comma P naught where under H naught is follow binomial NP naught such that um, such that is such that probability is less than C even H naught is less than equal to R. So these are the two tests we are going to check their power and behavior of their statistical power. Okay. Now, what we are going to do is, let's see, let us suppose we have this one. This one. Suppose N is, first we have to choose P naught, okay, and then suppose say P naught equal to 0.2, okay, and N equal to say 20 or even less, 15. And suppose your S is okay, Okay. Now, what will happen if this is the case that you have observed n is 15, s equal to 1? Okay. If this is the case, or then, or actually s doesn't matter here. S does not matter because for n equal to 1, can you compute the statistical power of the test 1? So now the question is, how we calculate the statistical power? So let me just go back and to the theory. Um, so in this case, if I have to calculate probability of, say, first let's say beta, which is probability of type 2 error. Probability of type 2 error. Now, probability of type 2 error is probability of fail to reject H naught when H naught is false. Correct? Now the problem is fail to, for the test 1, it will be like probability of P hat. Fail to reject means P hat is greater than C, but H naught is false. So H naught is false means P is less than P naught. But what P we will calculate? So what we have to assume that suppose P is some P1. Okay. For that P1, for that P1, we have to calculate that essentially what is the probability P hat is greater than C when P is equal to P1. Now, how can we do that? This is, we know what is this, C is C alpha, right? We can calculate this C alpha, that won't be a problem. And so probability P hat minus P1 divided by square root of P1 into 1 minus P1 square root of n is greater than square root of n C alpha minus P1 divided by square root of P1 into 1 minus P1 given P equal to P1. Are you guys all with me? Okay. This is definitely following normal distribution with standard deviation, mean 0, standard deviation 1. Because we know P hat follow some, so under null hypothesis, we can say this is following normal 0, 1. So essentially, we can compute from simple normal 0, 1, if it is 1 minus capital Phi of square root of n C alpha minus P1 square root of P1 into 1 minus P1. So this will be my beta or type 2 error. So my statistical power will be 1 minus beta. So this will be complete phi of square root of n C alpha minus P1 divided by square root of P1 into 1 minus P1. You guys are with me? Anybody have any doubt in this? Okay, if not, then I will just. So now what I will do first for n equal to this, I will calculate the C alpha. So what is C alpha? C alpha is P naught plus Z alpha times square root of P naught times 1 minus P naught divided by n. Now what I have to define, n is 15, P naught is 0.2, right? I have to figure out what is Z alpha. Just a minute. Okay, so now this is 0.2, and then now I have to figure out a Z alpha. Z alpha is Q norm 0 for alpha. We can, okay, first we have to also choose a alpha. So the alpha, let us take alpha to be 0.05. So the Q norm will be, okay, I have to put it in R. So Q norm is alpha. So this will give me the, so let me just run it, alpha. So Z alpha will be negative 1.64 and C alpha will be this. So C alpha will be 0.03. Why? It should not, right? Because ZA is negative, P naught is 0.2, square root of what is this? So Z alpha is negative this. So, what mistake we are making here?
Z alpha usually denotes the critical point where the area after that critical point is 5%.
Here I know.
So sir, यहाँ पे you have taken Q norm of alpha. Just you should like tell it that you have to not take the lower one, but the
No, that is not an issue. I think this is give me the correct Z alpha, negative 1.64. So this is 0.1. So if I just multiply this guy, this will be negative 0.169. So now P naught is 0.2. Okay, 0.03. Yeah, fine. So, okay. So C alpha is turning out to be 0.03. So that means, so my P naught is 0.2. So that is 20%. I'm doing a test for 20%. And so I need a C alpha to be okay. So unless it's saying that if it is P hat is less than, so this is for case one, that we are doing it for case one. No, case one, test one. This is the, when we are looking for test one, this is, let me just write it here. Test one. So this is fine. Now, so essentially, the thing is my C alpha is 0.03. So I'm doing a test for 20%. And if it is, I'm saying that my test region is P hat. So the test region is P hat less than 3%. Effectively, I will not reject. We will reject only if it is less than 3%. And then we have to calculate. Now we calculate type beta type 2 error, probability of type 2 error or statistical power. Okay, so now how we do that? So essentially, this will be P norm.
hello sir.
Yeah,
In the Q norm argument, shouldn't the lower tail set to false?
say it again.
In the Q norm function, shouldn't the lower tail be set to false?
Hmm. No, because I'm looking for the lower tail only now. What is my test? It's a left tail test. If you look into it, a left tail test. So I want the probability Z less than Z alpha. So definitely lower, I want lower tail to be true.
So you're defining Z alpha to be a critical value below which the probability is 5%.
Correct.
Okay.
So what is my type 1 error? If you look into my type 1 error, just a minute. Yeah. What is my type 1 error? So here I have made a mistake. I think it has to be P less than C. Sorry about that. P less than C. Such that, so if reject H naught, if P hat less than C. So if this so basically my type 1 error will be probability of P hat less than C given P naught equal to alpha, right? So this will, if you do the math, it will turn out to be probability Z less than Z alpha for P naught equal to alpha. So now you are looking for the left tail test. Okay.
Okay, sir.
So now I'm looking for power, statistical power. So power of test 1 is essentially P norm. Now, what we have, so square root of n times C alpha minus P1 divided by square root of P1 times 1 minus P1. Now I need to provide some value of P1. So suppose P1 is 0.1. So the null is 0.2. My power of the test is, in that case, will be 18%. So my probability of type 2 error, actually, let me just write it in this way, or probability of type error is 1 minus this guy, so that you will not have any problem with the definition. It will consistent with the definition. So this is the type 2 error. Type 2 error is 82%, very high, and power of the test is very low. So this is test 1. Now the question is, okay, fine. What about the test 2, which is based on the binomial proportion? So let us try to find the power of the test 2. Now, power of the test 2 is probability of power of test 2. That is what we are looking for. How can we calculate this? So remember that this is my reject H naught. So this guy is my reject H naught when H. So from here, I have to figure out what is the C alpha. First, that is what we have to figure out. So first, we figure out C when probability of S less than C given P equal to P naught x less than equal to alpha is follow binomial n P naught. Okay. So what I can do, what we have to do is basically we have to figure out from, we have to use, maybe we can use P binom function in R. And from P binom, we have to figure out or Q binom. Actually, I think Q binom could be the correct one. Yeah, probably Q binom is the right one. So basically what we need to figure out is which is less than equal to S naught will be P equal to P naught is less than equal to alpha, and probability is less than S naught plus 1 given P equal to P naught will be strictly greater than alpha. So then we can say C is equal to S naught. That is what we are going to do here. Okay, and we will use R to figure out. Now, what we are going to do, we can use Q binom 0.05 n equal to size equal to n. N is already there, yeah, size and probability equal to P naught. If I just run this, this will give me 1. Okay. So, yeah. So this is my C alpha. CA for C. I just want to write. So I have used C alpha for the test one. Let me just use CA for the. Yeah. So now this is my critical mass. Now, if I actually use, say, P binom, C A and size equal to n and probability equal to P0. So what does it mean? It means basically 1 for 1. So D binom 0 n P0. If I do that, that is 3%. Okay, and this plus D binom 1 comma n comma P1 P0. If I do, that is 16%. So my critical point should be 0, not 1, essentially. So less than equal to 0. So C alpha should be effectively -1. It should be -1. And then, all right, we get a 3, 5, or whatever that thing. So this is my critical value, and then what we have to do is calculate is probability of now let us go back to the power of test 2, which is um, probability of fail to reject when given H naught, and H naught is true, false, right? So what is fail to reject? Fail to reject is probability is greater than C when P equal to P1. That's all I have to calculate. So upper tail is greater than C upper tail when P equal to P1. That's it. So so that's all I have to calculate. So this is test 1 and this is for test 2. Right? Yeah, test 2. This is the critical point. Critical point. And now I'm looking for power of the test. The first, so power of test 1, the power of test 2 will be P binom. Now, what is my critical point? My critical point is this: size equal to n, probability equal to P1. Now I have to say lower tail equal to false because I want the probability is greater than C when P equal to P1. Okay. Now here power of the test turns out to be 79%. Okay. So now if I, so quite dramatic actually, C bind. I hope I'm not making any mistake.
So you calculated the probability of failing to reject. So that is type
Mm,
2.
yeah. So yeah, so it is showing significantly high. Yeah, it might be possible. I'm not saying it is not possible.
So you calculated type 2 error instead of power
Why type 2 error?
because you took the greater than equal to and
Yeah, that is the fail to reject now.
yeah, fail to reject basically means accepting, and accepting is
When fail to reject? When S is greater than C?
yeah.
Given that P equal to P1, that's all I am calculating, right?
Yeah, and that is type 2 error.
Oh, yes, yes. This is type 2 error. Fail to no. Yeah, this is type 2 error. Correct. So this will be my probability of type 2 error, then it is 1 minus type 2 error. Yeah. Yeah. Correct. Thanks. Yeah. So now if you see, yeah, absolutely correct. Thank you, Bhumika. That was correct. So now if you see probability of power of test 1 and power of test 2, given everything same, uh, it is for power of test 2 is better compared to the power of test 1. Can anybody guess why test 1 is doing better than test 1? Though essentially test 1 is based on sample proportion.
Sir, if n
Well,
is larger, then test one will perform better.
what? N is larger?
Then test one will perform better because it's we assume that it follow normal 0, 1.
Yeah, basically central limit theorem will work better in that case. Yeah, so the distributional assumptions is not working well for test 1. So when you have a when you have a small sample, at that time you should not run the test 1. So this is the reason that is how we decide which test to do. Okay. Instead of doing it ad hoc, just sample proportion and do a Z test. You can do that, but you can of course run the test 1 Z test, you can run the Z test, but it is better to do. Now you can ask me, sir, what about you have chosen ad hoc P1 to be 0.1. So one way of doing it is you write a function here for different values of P1 and calculate this powers and plot them. So one possible thing is that P1 is a sequence of numbers. So now calculate power. Okay, I'm done with the class. It's 11:45. Look quickly, let me see. For different value of P1. Okay, different value of P1. So P1 is sequence of number between 0 and P0. By 0.1 or 0.01, not 0.1. Yeah. So maybe I can just check 0.01. That will actually throw error. Yeah. So now what we can do, we can just write a, say maybe for loop and run these tests for each of the, calculate the power for each of these possible values of P1. Here you can see and calculate the P1s. Okay. Now, once you calculate the P1s, so you can write a for loop, and in each loop you calculate the power for different values of P1 and append them. Okay, and append them and create a basically table in which one column will have all the power of test 1, another column will have all the power of test 2, and then for different values of P1 you just do a R plot, like line plot, like how different values of P1 power is behaving. Okay, so I'm going to share this I'm going to assign it as a assignment. I'm going to do that, right? I'm thinking for it for a long time now, but I think it is now definitely overdue. So, okay, all right, I'll stop here. And let's meet tomorrow. Most likely, weather will continue. Let me just stop recording.